So hello guys, welcome back to my channel Code Shiva, and today we'll be solving a problem which is lead code problem number 78, which is subsets. Okay, so let's directly jump into the problem and see what it is. Now in this problem, the problem statement is like, given an integer array nums of unique elements, return all possible subsets. The solution set must not contain duplicate subsets. Return the solution in any order. So essentially whatever is being asked to us is this. At first we will be provided with a particular nums array which might contain elements like this, which might contain like 3 elements like this, and we are asked to find out the power set of this particular arrangement of numbers. Okay, so first of all, what really power set is? What is a power set? So power set is nothing but it is the combination of all of the elements within like all of the combinations of elements within this particular number. So in this case where 1 2 3 is here, we might have combinations like, first of all, we are taking 1, then we are taking 2, then we are taking 3 individually. Okay, then we are taking 1 comma 2, then we are taking 2 comma 3, then we are taking 3 comma 1. Okay, and at last we might include, like we will be including this null vector and 1 2 3. Okay, so this is the power set of this particular number. So we are asked to find the power set, and this how we like this is what our power set is. And this particular power set will contain 2 and 2 raised power n numbers. In this case, since n equals 3, we will be having 2 raised power 3 elements, which is 8. Okay, so a power set is the like collection of all of the subsets within this particular number, the collection of all the subsets including null and like where and the number itself. Okay, so this is what a power set is. And in this lead code problem number 78, which is subsets, we are asked to find all of the subsets and return it in a 2D vector. Like through a 2D vector we will be returning our result. So this is what is being asked to us in this problem. So the very first thing is that I would urge you guys to solve this problem by yourself. Like I'll just wait for 5 seconds. You can pause the video and you can come back if you aren't able to solve the problem or you just want a different approach to solve this problem. Okay, so I think by now you have already tried solving this problem, so I'll go ahead. Now to solve this problem we can have different approaches, and the very first approach to solve this problem might be recursive approach. Here we will be using recursion plus backtracking. So the intuition is this: since like when we are given these particular numbers, we will have like two choices. The first choice that we will take this particular number and the second choice which will come across us, which we will come across, is not taking this number. So if we take this particular number and this is the first level of our tree, if we're taking this particular number, then we will have a subset like this, and if we do not take this particular number, then we will be left out with the initial state of temporary subset. Okay, and at the second level, when we are asked to find, like, and at the second level we are asked whether we would want to take 2 within our subset or not, then we can take 2 or we cannot take 2. If we take 2, our subset will be this, and if we don't take, it will have no change in its form. And similarly we will have two options over here, whether to take 3 or not to take 3. Okay, now we are over here, whether to take 3 or not to take 3. 1 2 and then here 3. Like, let me just write it. 1 2 3, and if we don't take 3 it will be 1 2. So here are two subsets that we got. And similarly if we like backtrack and explore other branches, we will have many uh, different subsets as our answers. So like in this last level we will get all of the answers that are available over here, like all of the like possible all of the possible subsets of this particular number. We will get in, we will get that all of the possible subsets of this particular number, we will get it at the last level. Okay, and we will just be coding this particular logic, and we will understand like how things are to be implemented in recursion and backtracking, right? So like if I tell you how we will be implementing it, I'll just tell you from a broader perspective. So what we will be doing is, first in our recursive function, we might name it explore. Okay, in our recursive function we will first of all have a base case, and this base case will return us at this level. All of the elements at this level will be returned through a base case. And what can be our base case at this particular last level? At last level our base case can be like this. If our particular iteration is exceeding the total size of this particular array which was given to us as an input, then we will just return the particular subset that we have got, right? So this will be like if our I is greater, or if our I is greater than n, then we will be returning this particular subset. Okay, and then in the normal cases what we will be doing is, first we will take, because there are two options, right? So there should be two function calls. Like first of all I will be taking this particular element, then I'll be huh, first of all we will be taking this particular element, uh, and then we will pop out from subset, then we will pop out a particular last element from subset, and then we will not take, like we will just go on and call this function again, and then at last we will just be returning. So this is what our function structure would be. And obviously we will be taking particular this particular vector as an input, we will be taking this temp as an input, and we will be taking n as an input. So how many parameters we will be having are like these. So I think now logic part and explanation part is all completed. Let's move on to the implementation part and see how this problem is to be executed. So we can definitely take a result vector. uh, why do we need a result vector over here? Why do we need a result vector? First of all, as I've already told you that we will be having these temp vectors. These are all temporary subsets, these particular subsets are all temporary, but we need somewhere like this is a result vector. We need another vector which will enclose all of these subsets, all of these temporary subsets together, and that vector will be called a result vector. And since there will be the main function which will call, since like subsets function, right? since subsets function will call our explore function, and I don't really want to have this result vector as a parameter in this explore function, we can like do it in both ways. We can have a result function here, but then the problem would be nothing. We can obviously take this as a parameter, or we can have this result vector as a global variable, and we can like just do whatever logic we have to implement. So this is just the logic about how why do we need a global variable as a result. And let's take int n equals nums dot size. I will be taking my temp vector, then I'll be taking this explore, so now we will have our base case. Base case will be like if I is greater than n in any case, then we will be rest dot push back. Then we might be taking this as void if you're taking a particular element, then what we'll be doing is temp dot back nums of I, and then we'll call explore function, okay. And after like calling this function, we will pop back, and here we will explore the possibility of not taking that particular element, and after that we will just return. So let's just let me check my solution. Hmm. So there is a compile time error. We have not like told from where we are actually starting. We will be starting from 0. overflow. Hmm. I think we are getting ahead. Yes, we were actually. So the problem was that when we were taking this temp variable, we were exceeding like the ith value. Like if I is exactly equal to n, if in a case where I is exactly equal to n, it will cause heap buffer overflow because that value or that address doesn't really exist. So that was the problem with my code, and let's now just submit this particular solution and see if it works. So yeah, definitely this solution works. And in the next part of this video, what we will be doing is we will be learning about the next approach, which will be based on bit masking. And this approach is an iterative approach. So thank you guys for watching my video, and if you appreciate whatever I'm doing, then please like comment under this video, like, share, subscribe, everything like that. So okay, see you again